I want to talk a little bit about automation overall and the tool chain associated with it. So on, you've heard a little bit about various pieces of it today from Andre. And I'm going to start off with this, this definition, and because it's one thing I think about continuous delivery that is actually so compelling today, because it speaks to the business side of the equation, and it speaks, I think, the technical side of the equation for people. So, you know, for the business person, it's about delivering better value faster. It's about faster time to market. It's about lowering risk and so on. But by the same token, if you're the VP of engineering, it's about keeping your pipeline full and flowing, full of feature and function all the time. If you're the QA person, it's about making sure you can deliver better quality software in a better fashion. So it kind of helps pull these things together. And one of the common reasons I think we're all here is because we have an interest in continuous delivery, but also want to learn also a little bit about Jenkins and its role in it. And really, Jenkins was born of continuous integration, but what continuous delivery fundamentally does is add the concept of release readiness at all times to that picture. Okay, so that's really the extension beyond what I think we've all been used to for some time on continuous integration. I am working at CloudBees, and we have a continuous delivery platform that is built around Jenkins at its heart. And so that allows us to present a solution that speaks really to the development teams, but also increasingly the platform and Jenkins overall is being used to address the operational side of the equation. And there is a big movement for DevOps, so moving the development and ops teams together and helping them work more closely together. So whether you're in development or you're in ops or you are making a movement as an organization towards a DevOps type of process, the platform can help address that. And whether you're deploying to a platform as a service, like CloudBees' own platform as a service, or to App Engine, or to Beanstalk and so on, to the public cloud, or to your own internal infrastructure, whether you're moving towards a cloud-based infrastructure as a service internally, or you have more traditional stuff, the platform is designed to address those. So kind of to set the context properly, I think it's useful to talk a little bit about what continuous delivery is and is not, because you know, we look at examples like Netflix or Etsy and so on, and these are fantastic, I think, visionary examples of how you would all like to be. But everybody is not a Netflix. And so when we talk about continuous delivery, we are really talking about keeping your software in a release-ready state at all times. That does not mean that if you are not deploying to production constantly, you can't do continuous delivery. Okay, you can do continuous delivery. You can approach continuous delivery rather incrementally. Okay, so as long as you are producing your piece of software and handing it off to a downstream team in a release-ready state for it to be consumed, from my perspective, you are practicing continuous delivery. And you can adopt that kind of strategy in your organization to expand out and achieve continuous delivery in a more organizational-wide fashion. In a lot of organizations, delivering directly to production is dead on arrival. So that's an English acronym that maybe many of you are not familiar with. But it's just simply, it's not even open for discussion. We have regulatory requirements and things like that we have to fit within. You're not deploying to production whenever you want. But that, again, does not mean you can't do continuous delivery. The other thing I think that Andre touched on is that you really would like to have a kind of a top-down endorsement that this is what you're doing. And it's one of the great things about continuous delivery. If you're doing continuous integration, you're the QA guy and the software engineering guy, and it's kind of this esoteric thing off in the corner that the business guy doesn't care that much about. But if you're doing continuous delivery, part of the value of it is to be able to continually deliver new feature functionality, new operability continuously. So you would like to have a wholesale adoption across your organization, but you can really do that between teams within the organization also. And while it benefits, and it ultimately will succeed best if you have really a top-down notion of doing that, and that's how companies like Netflix and Amazon and so on did it. They actually had the top person say, this is what we're going to go do. And that causes interesting things to happen in an organization. So if you can get that endorsement, then that really will push it. But you can start lower and push it up and then gain that endorsement also. Okay? And then we talked about DevOps. I think it's worthwhile to spend a little bit of time talking about DevOps as a phenomenon and so on. And this is the Wikipedia definition of DevOps. And it's about collaboration and so on and so forth, and roses and nice music and so on. If you are delivering as a service, so if you are delivering an external service that's consumed by your business partners or downstream teams, then I think you are somewhat naturally pushed towards a continuous delivery mode where development and ops responsibility can be shared more easily because you have this shared goal, really, which is to deliver service to your end users. Okay, so if you are moving to DevOps as a style, then continuous delivery is typically part of that, right? So they overlap, I think, extensively in terms of what you hear today. You hear people talking about DevOps. It really means delivering both functionality and operability together and sharing that responsibility between teams. So you can formalize your team structure more towards development processes and ops processes, but it's really that accountability and finding that shared goal between the teams that really makes, I think, ultimately the big difference here. And you hear about the 8 tenets of continuous delivery and so on. Well, everybody should be doing this, of course. It seems like it's the answer to everything at this point in time, but it is actually really, really hard to do. And I am going to talk about the tool chain and automation and things like that, but I think it's worthwhile to point out that organizational and cultural issues in your company are most likely at the top of the list in terms of blockers why continuous delivery is hard. And just adopting a tool does not, of course, solve that problem. Okay, now I am a big believer, however, in the fact that when you do adopt a tool or a set of tools, those can serve as kind of catalysts to helping you achieve this goal. Okay, so I think the selection of the right tool chain can help you transform your organization, and the selection of the wrong one will hinder you from achieving that goal. But ultimately, it's very hard to do. Most of the barriers to getting to continuous delivery are not about technology, they're really about organization. And but the fact of the matter is that lots of people are doing this, and this is from a survey done by our friends at Zebia Labs that I just shamelessly stole and put here. And that is when they went out and surveyed organizations, amazingly, more than half of them said that what they were doing was aiming at continuous delivery as a goal for the coming year. And I thought was even more interesting is that out of those organizations that reported that, even more of them reported they had top-down buy-in for that. Again, which is sort of this critical factor. If you can get that top-down buy-in, because it's really about moving things all the way through the value stream as fast as you can, then you have ultimately a lot better chance of success in doing it. Okay, so let's move from that to talking a little bit about the tool chain itself. So what kind of tools do you choose to solve this problem? Why do you choose those tools? How do they intersect with some of your goals along the way? So I like to start here. So can I ask, since a lot of people are familiar with Jenkins here, how many people are actually doing, would you say you are doing continuous integration today? Okay, a whole lot of people. That's really great. So, so this is, I think, just like continuous integration in a nutshell, but it's basically to say that continuous integration really is driven from the development organization. So development wants to produce code better, faster. I love to talk about error discovery and culture and so on. Continuously, think about continuous integration, how it fits with that. It's a nice fit because you want that fast feedback loop. You want to discover errors rapidly, and you want it to be normal to discover and fix errors all the time so that you can keep things running constantly all the time. So the way I like to think about this problem then is that there are a set of artifacts that the development team uses to get their jobs done. So if you're a development person, you know what those are. Their source code, their configuration, set of tests you write against it, and so on. You use some kind of build system, and there are a variety of them. There's everything from Ant and Maven and Gradle and so on. Depends on what you're doing, what kind of code you're writing, what kind of system you use, some kind of packager to package up your code into some kind of acceptable form for deployment. And then you end up with these packages, whether it's a WAR file for a Java program or an APK or something like that. And so you choose a tool chain to actually deal with the artifacts that you're using underneath the covers. So you choose a source code repository, you choose a continuous integration server, you should be storing your binaries separate from your source code in a separate artifact repository typically. And as people push code changes in, kicks off the continuous integration server. The continuous integration server kicks off tests, which may kick off more tests, which ultimately produce artifacts, which are then stored in the repository. And so this continuous integration piece, again, from the development sort of side of the house, gets pushed into continuous delivery, really as emerging from the need to test things. So to do functional testing, to take the artifacts that you've created and stored in some kind of artifact repository and pushing them out for testing, for functional testing, for integration testing, for stress testing, system testing, and so on. So again, you have a set of artifacts, you have a provisioning system and configuration automation system, and you have a set of tools that you use to push those things out. And then that allows you to automate your development process for building and doing unit testing and so on, but push out to a staging area typically, and from the staging area to run tests against those to validate things are working and to extend that continuous delivery functional fast feedback loop through the deployment process also. And then on the ops side of the house, they have a very, very similar tool chain choice. Actually, I'm kind of interested. Would you declare yourselves to be dev people or ops people? Which would be ops people in the house? Yeah, see, that's what's common. Who are these ops people? What do they do for a living? So I think one of the key parts is to understand what your ops people are doing and dealing with is part of the trick here. And so when you look at the ops side of things, they are dealing with the same kind of artifacts, right? But instead of code, they're dealing with environment definitions. They have tests. They run tests against things before they deploy them. They have their own packaging systems. Instead of pushing WAR files and things like that, they're typically pushing out system images that get deployed in some kind of virtualized environment. So they have a very, very similar set of issues to solve, and yet they have a different set of artifacts. And then just to point out, when we talk about treating configuration as code, comes very natural for the development side of the house. But from the ops side of the house, what this really means is capturing those specifications and environments, committing them to a source code system, and tracking the changes so that as those changes take place, they can be deployed in a reproducible manner, potentially rolled back, and so on. So when we talk about treating configuration as code, this is what we're talking about. So you have the two kind of sides going from sort of the build sort of side of things towards the staging or an ops side, ultimately deployment to production side. And the tool chains are kind of similar, but they're also kind of different. So if you're a developer guy, you go like, GitHub, that's great. That's what I'm using. But if you are on the ops side of the house, or you're potentially coming from more of the software engineering structure side of the house, sometimes they just don't want to hear about a distributed version control system, and they sure don't want to hear about one that's hosted on the open internet. So, they push for different solutions. So, perforce, a centralized version control system is often the tool of choice on that side. How you store and manipulate the artifacts, again, is a different choice. You hang your processes internally off of these toolchain choices. It turns out that Jenkins is an incredibly common unifying element of these two teams, because they both find this to be useful as a tool to them as changes are made to kick off a continuous integration process, which then runs tests and moves these artifacts along. As you move towards the deployment side, the developers, being the smart, lazy types they are, love the platform as a service, so they can push code out and not worry about the details underneath the covers, how things are wired together. I can just let the CloudBees paths deal with that, or Heroku deal with that. That works for me. That is seldom, frankly, on the minds of the ops people. They do not want that. What they want is they want control over that infrastructure, because they have other worries. They have to worry about updating operating systems, things like that. They have to live within the constraints of regulatory processes, security constraints, and things like this. So, but they do want to automate that, and so they often make choices for tools like Puppet for infrastructure automation, Chef for infrastructure automation. They start thinking about tools that address existing middleware, complex middleware configurations and things like that, more like the Midvision solutions or the Zebia Labs Deploy It solutions, which have much deeper integration with existing systems in some fashion, whereas Chef and Puppet give you this incredible flexibility for defining a target system and manipulating that directly. Okay, so you have these different tool chains intersecting in a lot of ways at Jenkins. Andre referred to it as a hub of continuous delivery, and this is why, because I think it satisfies both sides of the house, from development all the way through deployment. So the other thing is that I think these factions, the development people and the ops people, have different viewpoints on things, right? The development people are all about, like, I need to get this stuff done. I want to use this language, this tool. It just makes my life easier. I can turn things around faster. I came from a development organization. I've lived in one for a long time. I would say developers, I think, favor what I think of as local optimization. My team needs to turn around its deliverable faster. And that's what they see, and that's what they do. Whereas ops guys often have to deal with the larger scale throughput issue that Andre was talking about. So it might not be locally optimized for you, Mr. Developer, but it actually improves my throughput if I'm looking at the overall process here. And so that's often what the ops people are looking at. They have to deal with auditing, security things, all these things that developer guys just find annoying and try to avoid at all costs. A lot of constraints, a lot of legacy issues, And in fact, Jenkins finds itself as a great tool for common ground between these guys. And we're going to have a talk from somebody from Puppet Labs here today, which is going to be great. But just, we talk about infrastructure and code and so on. So if you are not familiar with the concept, you should be familiar with the concept when you're looking at automating infrastructure. You can look at Puppet, Chef. There are other options out there also, like Ansible and SaltStack. What do these things do? We talk about like treating infrastructure as code. What they do is they are tools to let you define a system in some fashion declaratively. You can define the specification for that system, and then you make changes to that configuration. As you make changes to those configuration, you can push in a reproducible fashion what you've changed to this target configuration. So whether it's an app like a web app or something like that, then Chef and Puppet know that when you make the change, push that web app out there, it has to be deployed across n number of servers, which themselves have to be connected and deal with other database servers or be front-ended by a proxy server. All those complex system definitions are part of what Chef and Puppet are helping you automate in terms of the deployment process. And from the development team's standpoint, those are also just as valuable for you to set up staging areas. Of course, if the ultimate thing for continuous delivery is to have those systems be the same, but at least you should have them created the same. So you don't end up with that, well, I tested this in the staging area, it worked fine, I don't know why it's not working over here. So it's to eliminate that impedance mismatch also. These are important tools in your toolchain choice. And then the ops teams, again, back to the development people having some insight into what ops teams have to deal with. They have to deal with your existing systems for identity and access management, release management, change control overall, and so on and so forth. There's just a tremendous number of constraints and systems that have to be dealt with in the overall process to automate continuous delivery. And one of the most important things I think you learn as you do this is that, and I think a lot of people just know this because they've lived through it for so long, is that nobody is doing you a favor when they walk in and tell you, I have this great continuous delivery solution for you. All you have to do is change this system here, that system here, and that system here to give you a complete solution. Instead, what you really need is you need to make toolchain choices that fit with your environment and your constraints. Okay, and this is frankly one of the reasons that Jenkins finds itself in the middle of continuous delivery, is because it does connect to those systems in a variety of ways, and it does not force you to adapt your existing systems to it. It's just great at adapting to your existing systems. And then the last thing I want to say on the topic is that when you do mobile testing, it's an entirely different world. It's amazingly different, and you could spend an entire talk or two or a week or three or whatever it is talking about mobile testing. But it's a huge challenge for people, because even people have been doing continuous integration for a long time and they're already into agile processes and so on, find when they move to the mobile world that the equation is different. You have an entire set of build tools that are more or less dictated to you by, if you're doing Android or iOS, you must choose Xcode and you must choose Gradle effectively, because that's where Android is going. There's a whole, how do you do A/B testing? Well, I already know how to do that on my website. I can just make a change here, make a change here. I can measure things that are going on. How do you do that in a mobile world? Very different. There are tools to do that, like Vessel and so on. Well, how do I do continuous delivery when delivery requires me to go through an app store? What's that about? Well, there are tools like Appaloosa and TestFlight where they will help you do delivery in a beta form. So it does not go through the app store, so you can do beta testing of your mobile applications, but you have to bypass that. Bypass the app store itself to do that kind of continuous delivery and feedback as you develop things. What about testing this stuff? Well, you know, there's specific tools built around mobile testing. We've mentioned SOSTA a number of times. They have a great tool for doing touch testing. They also have great tools for doing cloud-based load testing too, which is huge. It's a huge part. You don't understand often your load and how it propagates through your back-end systems and these new mobile devices. You're worried about success. When I get lots of people using it, what's going to happen? How do I scale up? These systems are there. And then there's a huge issue with devices themselves. Of course, if you're doing iOS, you have a fairly controlled environment, but with Android, it's just a nightmare in terms of form factor. There's regional aspects and so on and so forth. And while there are emulators from these organizations that you can use as part of your tool chain, great for automation. You can use emulators to do testing against, but the emulators don't deal with like location services properly. So you ultimately have to do device level testing. There are a whole set of services that are available for hosted devices, and you can do those through cloud-based testing. People host these devices for you, and then there's solutions like SOSTA has to help you build up your own mobile testing lab in-house if that doesn't work for you. So again, it's a very different world for the mobile tool chain and mobile choices too. Jenkins, again, does a great job in this arena. So for example, how you deal with provisioning profiles. So a lot of the mobile stuff is built around like one person with a phone attached to their Mac, go at it. But if you have a team of 100 people and they all have role-based access control, and you have specific provisioning profiles for your final app that goes out that you have to control tightly, yet you want people to do development, how do you deal with that? There's a lot of power already built into Jenkins to deal with those solutions too. Okay, I want to spend just a little bit of time talking about the platform that CloudBees provides. And this is a bit of a logo chart. But the idea here is that using Jenkins in our platform, we are able to address the full life cycle from building and testing through staging, deployment, and actually running your application. Again, Jenkins comes with a lot of facilities to reach to existing systems, your existing tool chain choices, whether it's Git or Subversion, whether it's Maven or Gradle, to connect to and use best-of-breed solutions like SOSTA and Midvision and so on to get those systems tied together. And one of the things that CloudBees has done is done a great job of this to connect this, either whether you're running it on-premise with your own sort of existing toolchain solutions, at scale on-premise with a whole bunch of Jenkins load going on, how you connect those, how you manage those, and so on, or you're using cloud-based solutions, whether it's hosted on CloudBees itself or connected to other providers. The platform is very, very capable of doing that. So hopefully you'll come talk to us and hear a little bit more about that. We have introduced some new feature functionality in there. If you're an existing Jenkins user, you know that you can make use of the EC2 plugin to connect and use Amazon EC2 resources on demand, scale it up, scale it down, knock them down when you're not using them. You can use vSphere to do the same kind of thing. And we've recently introduced an Elastic Cloud Pool plugin. So again, from Jenkins, whether you're using open source Jenkins or you're using CloudBees, Jenkins Enterprise by CloudBees or Operations Center by CloudBees, you can now just connect to an existing pool of Jenkins executors, which are fully managed by CloudBees, and make use of those. So you get this sort of instant on ability, you get the large scale that CloudBees has, since we're doing this across thousands of users that are fully isolated and so on. So you also, since we are using container-based technology in our cloud-based solution, things spin up in an isolated environment. There's no pollution between your code execution and so on. So it's pretty cool. And another thing we've recently introduced, and I think Kosuke will talk a little bit more about this, is improvements in traceability. So we talked about Puppet and Chef, and a very common pattern for usage of Puppet and Chef between the dev teams and the ops teams is the dev teams will create something, and drop it in an artifact repository, and move on. Drop something in the artifact repository and move on. And Jenkins is controlling that. And then somewhere, sometime, the ops guy will decide, well, it's time to push the button and put that in production, and that will happen. And it's how do you connect those events together has been a bit of a challenge. So we added some capabilities. Jenkins already had a capability to track fingerprints of artifacts, basically a hash of the files that are created during that. And with this traceability end-to-end like this, then you get an ability to answer questions like, well, did this security fix make it out into production? Or is this system running it or not? So the way this works is from the development side, somebody pushes some code in, kicks off Jenkins, stores artifacts. The artifacts have a fingerprint associated with them. The ops person kicks off Puppet and Chef to deploy one of those artifacts. The artifact goes off and may deploy, let's say, a WAR file to an app server of some kind. And you end up with this fingerprint traceability all the way then from code change into deployment. So instead of just knowing that build number 4 executed at this time and created this artifact, you now know that the build number 4, which included a security fix for this known issue, is running live on this particular instance that was deployed using Puppet or Chef. And Puppet and Chef do this by calling back to Jenkins to notify it. So back from Jenkins, you have this unified view of this. And then the last thing that I want to give you a little bit of a preview here on is on something we've just introduced into Jenkins open source, which is an ability to define workflows more simply in Jenkins. So this is a picture of how you would do a workflow, a build pipeline in Jenkins. So I like this picture because our friend Andrew Phillips and Kosuke did this nice article about it. But this picture in the upper left is how you might think of a workflow, right? You have a sort of development process, you have a QA piece where people are doing more testing at scale, and then you make a business decision about whether to deploy the thing. And it looks like this, and there's multiple things going on in parallel, and this is the way you think about it. But the way you see this in Jenkins is a bunch of build jobs, okay? And so it's kind of hard to piece those together. Each one has a configuration that sort of knits those jobs together and defines the flow. It's kind of embedded in it. There are a number of plugins that are required to do this with multiple jobs. When something fails someplace in the middle of this workflow, it's kind of tough to figure out what do I do. There were 2-3 things running in parallel here and so on. And they're also, because they're specific build jobs, it sort of limits the amount of reusability that goes on. So this is something we've just introduced. It's out there in beta form for your download and usage with Jenkins, which is a new workflow. It introduces a workflow job type. So instead of those 10 jobs to capture that workflow, you can define the workflow in one place. It's text-based, which is good. So there's a text file that allows you to define using a Groovy language. You can insert using a domain-specific language to talk to Jenkins and invoke steps and actions within it. When things fail, you can retry them. We're introducing an ability to do checkpointing in that also. And because it's text-based, it also helps with the reusability of it. So let's say the hard part underneath the covers is there for you today. You can try it out. There will be new visualizations coming and things like this. So this is going to be, I think, a real big step forward for Jenkins and continuous delivery just to make things easier. So come to the Jenkins user conference and hear more about it. I think Kosuke will tell you a little bit more about it this afternoon after lunch also. Okay, so in conclusion, You know, there's these two, I think of that as a development and an ops sort of tool chain. They each have a development process they want to follow. As they make changes, they want to do continuous integration and test before things are deployed. These two tool chains intersect. Jenkins is a great place to find that intersection and to bridge between these teams. CloudBees is offering you a platform that helps pull these together, helps you operate them at scale, helps you bridge that in your existing organization between your on-premise usage and your cloud-based usage. And we're continuing to invest in Jenkins, and Jenkins itself, I think, is becoming the de facto tool for orchestrating continuous delivery across the enterprise, and there's lots of new things happening there. So that's it. Time for a few questions, if there are any. Okay. Thank you.